today, just as the chair of this webinar has just introduced, is on intelligent sensor systems and edge AI for the next generation smart healthcare and IoT applications. So as we know, generally the convergence of microsystems technology with embedded intelligence and artificial intelligence is transforming how we monitor, how we analyze, and also how we interact with the physical world. So today I will be discussing how intelligent sensors and also edge AI are enabling smarter healthcare systems, more efficient IoT platforms, and also sustainable digital innovation. So permit me to proceed if every other things are in order. I will now proceed with my presentation. The overview of the webinar is just as you can see on the screen as well. First, I will introduce the motivation behind intelligent sensing technologies. We then move on to discuss the intelligent sensor ecosystems and also the micro electromechanical systems and also smart sensors technologies. I will then move to introduce edge AI, what it can do, and also present a layered architecture for intelligent sensing systems. Then I will now move on to take one case study, which is, I will take two case studies, but I will concentrate more on one. So, which is on the healthcare case study, which we now be able to, which we are going to use to demonstrate a practical implementation of this intelligent sensor system. Finally, we will discuss applications, challenges, future directions, and we will conclude with questions and discussion or questions and answers. Now, why intelligent sensor systems matter? Intelligent sensor systems have already become the foundational technologies for modern digital transformation. So if you look at this slide, we are going to move from driving a smarter, healthier and sustainable future. We'll be looking into smart healthcare, how we're going to sense everything around human bodies or everything around organisms, how we are going to interact to be able to send it to where it's going to, where we're going to analyze the system. So intelligent sensor system, just as I mentioned, has become one of the modern digital transformation. In healthcare especially, they enable continuous patient monitoring and early disease detection. So in IoT environment, they help to connect physical objects to digital intelligence. In the terms of Industry 4.0, which we call the fourth industrial revolution, of course, which is the digital transformation of manufacturing and supply chains, this relies heavily on sensors. And these sensors for automation, for predicting maintenance, and also for quality control. They also contribute to sustainability by enabling efficient resource utilization and also intelligent decision making. So when you sense any stimuli outside the electronic system, which is of course in the outer world, that particular information needs to be disseminated to where it's going to be analyzed. So sensors has become the key or the eyes and ears of smart systems. Now, the intelligent sensor ecosystem, which we have to now dwell in to see what happens when environment need to be sensed and how do we analyze, how do we take decision based on the information. So from the physical world to intelligent decision, and that is what this particular webinar is all about. So an intelligent sensing system is much more than just the sensors. The process begins with sensing the physical environment. Then while that information that is sensed or those signals that are sensed, the sensors signals are then conditioned and also digitalized so that our electronics are able to see what happened in the real world. Then embedded processors will now then perform some local computation Then we adopt the artificial intelligence algorithm to now analyze the data that is being processed and again extract meaningful insight, whether it is either good or if there's a deformities in any of whatever we are sensing, then that needs to be communicated through a technologies, or that is communication technology will now have to transfer that information when necessary. Otherwise, it might have to abandon it or store it somewhere. Finally, a decision or action need to be taken automatically on by human operators, so that when it says to maybe a medical doctor or any health practitioner is able to take decision based on the analysis. So this is a complete ecosystem that creates intelligence autonomous system, from the environment to the sensors to signal conditioning, embedded edge processors. Instead of sending our information to the cloud, we can process that information from the system itself. Then we have what we call the AI inference engine, where we're able to classify the information based on what is being processed at the embedded edge processors. Then that information is going to be transmitted to who is going to take the decision via the communication layer. That can either be Bluetooth, LoRa, or any other communication technologies. Then a decision is now going to be taken by whosoever that needs to take that information. So the sensors that we are going to be using to be able to sense the environment, as you can see, we have the MEMS, which I've already explained, and also the smart sensors. So this enables a precise decision. In this, you will find out that these MEMS and smart sensors, they can now be embedded into any device that should be able to sense the environment. So generally, MEMS sensors, just as I mentioned before, they are the foundation for modern intelligence sensing. So MEMS stand, of course, what I've mentioned before, is just micro electromechanical systems. And this device integrates sensors, actuators, and other electronics on a single chip. And that is just a chip which you can see here. Examples of such are like the biosensors, the pressure sensors, the microphones, and the rest. They are very small. They are small in size, low power consumption. That is why they are mostly used these days. They are highly sensitive, low cost, and they are highly reliable as well. So this characteristics makes these MEMS ideal for most of the healthcare devices that are being used to sense the external stimuli. Now, why do we employ Edge AI? Because in the olden days, what is normally being done is that you sense information, send to the cloud, a powerful computer process it, send it back to whoso is going to take the decision. That takes a lot of time. There's a lot of delay in that process. So now with the advent of Edge AI, we're able to process those information within the gadget itself. So there is now intelligent processing at that particular system instead of sending to a particular storage place for the information to be processed. So traditionally, sensor data used to be transmitted to the cloud for processing. But with the advent of Edge AI, that has now minimized the time wastage and other issues along sending those information. So this approach introduced, the traditional approach normally introduced latency, which I've already talked about, bandwidth consumptions, privacy concerns, and also dependency on connectivity. If there is no connection, then you will not be able to process the information that is being sensed in the external world. So Edge AI solved these problems by now moving intelligence close to the data source itself. Instead of sending all those data to the cloud, AI algorithm now executes directly on the edge device. So with that, a lot of benefits now comes in. For example, the real-time decision-making, improve privacy, reduce latency, that is delay, reduce bandwidth requirement as well, and also greater reliability. So Edge AI is now becoming the key for enabling intelligent healthcare and also other IoT application. But colleagues, if you feel that there is a place you need clarification while I proceed, just let me know so that we don't need to get to the end of the webinar before we ask questions. A general architecture of what we are talking about, that is the intelligent sensor systems. This with now Edge AI embedded is what I just is on this slide. So this layered architecture enable real-time data acquisition, intelligent processing at the edge, secure communications, and also insight generation. So this is just a general architecture of intelligent sensor ecosystem with an edge AI. So the slides just illustrates the complete architecture for the intelligent sensor system, which is now integrated with the edge AI. So at the bottom layer, you will find MEMS and smart sensors. We collect information. Now this information, or the signals, are now being conditioned or prepare and also prepare the data for digital processing at the DSP side. So embedded processor will now execute machine learning and deep learning models locally instead of transmitting to the cloud. Now we now employ the communication, which can now be either Wi-Fi, BLE, LoRa, and all the rest, or cellular network, to be able to send those information to whosoever is going to maybe take decision. Now, cloud, if need to, go to the cloud. But otherwise, in some cases, if the information is already being processed at the edge, then no need to send to the cloud. That is now transmitted directly to the end user or the healthcare healthcare practitioner who is going to take a decision for the personnel. So this result is scalable, and intelligent architecture is now capable of supporting numerous real-world applications instead of maybe sending straight to the cloud. Now, one of the examples which I've said I'm going to touch base on is the AI-based cardiac monitoring system. Now, in the AI-based cardiac monitoring system, we can use different sensors, including the PPG sensors, other sensors like the temperature sensors, the SPO sensors. We can use that on the device itself to sense information on the human body. So in this case, we found out that we can adopt the edge AI, and also so that we're able to process our information instead of sending them to the cloud. So the data that we're going to send undergoes pre-processing first, and now feature extraction is now being done, where AI models will now analyze this signal so that we're able to identify abnormalities in the human bodies. So with that, potential application, just as I've mentioned, includes the heart rate monitoring, and the arrhythmia detection, remote patient monitoring, early disease detection, and the rest. So such system will now reduce healthcare costs while also improving accessibility and patient outcomes. So this is one of the examples, and I will go into what we've just invented recently, which has also been filed for patent as well, which is the AI-based cardiac monitoring system. This is just the architecture for that particular system, where we employ the CNN and GRU for our processing and decision making. So where we are able to sense information like the photography. So which, of course, in this case, we sense information using the non-invasive optical sensing techniques. Then in this, we are able to get the features of whatever that we sense, create a learning model, classify them, and now get an output, which can either be normal or abnormal. So, but how does this PPG actually work? It's an LED will emit light into the skin, where blood vessel will now absorb that particular light. Photo detector will now measure the reflected or the transmitted light. Variation in the blood volumes, during each of the heartbeat, we now have to produce the PPG waveform. Then in that, we are now able to move that particular signal into the other phase, which of course is the convolutional neural network phase, where we are able to detect the features. So after that, we move that particular signal is moved to the GRU, which is the gated recurrent unit. In that, the hybrid learning architecture is combined with the CNN and the GRU. so that we're able to extract spatial features of whatever that we sense on the PPG's signals. Then we're able to classify, whatever we've seen, then to be able to detect whether it's normal or abnormal. So that is one of our invention. And the other invention is automated vaccine administration system, which of course, in this one, the university will file it through PCT, which was examined in US, and it has about 31 claims, and all the 31 claims came back to us as having been all novel, having inventive steps, and also their industrial applicability also was found worthy of patentability. So in this, what the system does again is we try to, instead of using the normal vaccination where you have to normally administer this vaccine into animals or human beings, we try to automate them again using sensors. So what we do is that if you have thousands of animals like cattle, goat, whatever, you can pass them through a specific channel where we're able to sense them that wherever they are passing. Then after sensing, we are able to also automatically draw a vaccine dosage based on their weight and then give them the injection, while we also sense their tag and store those particular ID of each of the animals in the cloud. And with that, we're able to automate vaccination as well. So this is another invention which we just invented and also already patented. But then, even after all those, we need to communicate all the information to whosoever that is going to take decision. So we also have other IoT application. In this, we just as the chair of this particular webinar has just introduced, I specialize in sensors and systems, most especially in wireless sensor network. So wireless sensor network form, of course, the communication backbones of many intelligence sensing systems. Without wireless sensor network, you are not able to coordinate the information and send to a central point for decision making. So this, we are able to collect information, a gateway, aggregate those information, and connect them to the cloud servers. Then the key decision objective is mostly the key design objective for wireless sensor network is energy efficiency, scalability, latency, reliability, and all that. So all those are embedded in wireless sensor network design. Most application of the wireless sensor network is we normally use them for agriculture, environmental monitoring, just like what I've just explained. You can have a bunch of sensors embedded in human body. All the information are sensed and wirelessly transmitted to a central place. So also we have others like industrial automation, also healthcare, just as I've mentioned, and also smart cities. Other applications, just as I've mentioned, healthcare, agriculture, industries, smart cities, and environment, which I've already mentioned, they are also part of the applications of wireless sensor system. So we use those we monitor from the real world and to intelligent decision making. So intelligent sensor system and edge AI now they are powering the future of our everyday doing. So without intelligent sensor system and edge AI, most of our decisions either get slow or they are not even being taken.
Prof.
Yes.
In terms of the healthcare,
yes,
I think one of the challenge is data privacy, right, among the patient.
Yes.
Yeah. Yes. How do you tackle this one?
And that is why I was mentioning the other time, in the olden days, what happened is for you to be able to transmit those information to the healthcare practitioner, you need to send them or store them somewhere or send to the cloud, which indirectly you don't know who have access to those information. Now, instead of that, as this sense, the information is processed directly from the device itself. That is where the edge AI now comes in. And that is transmitted straight to whosoever that's going to take decisions. So that privacy is now okay at that particular system, because it's now between the user and the decision maker. Remember, the decision maker now is your healthcare practitioner, like your medical doctor or a nurse or whosoever. So that is where the edge AI now come in, instead of sending the information to the cloud.
So, mean that you are doing in Botswana now,
Yes, it's part of what I just told you, that we just patented as well, the AI cardiac monitoring system.
Okay, thanks.
Yes. So what are the challenges? Even though these have a lot of application, there is nothing that you cannot find challenges. What are the challenges? Now, despite the significant progress that has been done in this smart sensing system with inclusion of the edge AI, despite those, there are several challenges which still remain, like the power and energy constraint, which is the main issue with sensors in the sensor networks. So this limits long-term deployment. Security and privacy concerns become increasingly important if edge AI is not embedded, and more devices become connected. So you have an issue of interoperability. So that means interoperability issue also arises because devices often use different standards and protocols. So now we need to find a way for those devices that use different protocols and standards to be able to negotiate or to be able to agree with each other, so that information are shared seamlessly. So AI explainability remains also a major concern, especially in healthcare application. Deployment and scalability challenges must also be addressed, especially when we have large-scale adoption. So you might have thousands of people or thousands of animals or thousands of machines, and you need to sense them and take decision at once. So deployment of these sensors also in a large environment also is another challenge. So addressing all these challenges will require multidisciplinary collaboration and innovation. And that is where this webinar will open up for collaboration with anyone who is listening to our webinar, so that we are able to design and have a seamless sensing systems. So with this, what are the future directions? Looking ahead, several trends will shape the future of intelligent systems, even though we've already mentioned the challenges. Edge AI models will become more efficient and capable. Sensing technologies will continue to improve accuracy, reliability, and miniaturization if the interoperability issue is being solved. The emergence of 5G and eventually 6G and beyond will enable ultra-low latency connectivity because of the latency issues. Federated learning will also improve privacy while also supporting distributed intelligence. Sustainability will become a key design requirement. Ultimately, intelligent sensing system will become increasingly autonomous, adaptive, and human-centered if all these are taken on board. In conclusion, intelligent sensor systems are becoming essential components of modern digital ecosystems. MEMS technologies provide the sensing foundation, because now it's now in one chip instead of distributed sensors. Edge AI enables real-time intelligence and automated decision-making instead of sending to the cloud. All the information are processed within the system itself. And of course, which now reduce the latency and also security issues. Together, these technologies will now transform healthcare, IoT, industrial automation, and sustainability or sustainable development. The future belongs to systems that can sense, learn, reason, and act intelligence, that is where the intelligent sensor system and edge AI now become the future of these applications such as healthcare, IoT, industrial automation, and the like. I don't want to finish my presentation without acknowledging the research collaborators, my student and research team, University of Botswana as a whole, MiCTEC centers. The webinar organizers, I want to thank you all for allowing me to share my little experience with you, where we also are going to discuss on some of the things as we proceed in our collaboration. Thank you so much. I will now entertain questions so that we can discuss them and find a better way where intelligent sensors dominate the world. Thank you so much.
Okay, thank you, Prof. So we have from Edwin.